Imagine a world made not of tiny atoms, but of even tinier vibrating strings. These strings are so small that they are beyond the reach of our most powerful microscopes. They exist in a realm that is almost unimaginable. A world where the very fabric of reality is woven from these minuscule threads. These strings, way smaller than anything we can see now, are the basic building blocks of everything, according to string theory. This theory suggests that all the different particles we observe are actually different vibrational modes of these fundamental strings. Just as a guitar string can produce different notes depending on how it vibrates, these cosmic strings can create different particles. Like the strings on a cello making different notes by vibrating differently, these cosmic strings vibrate in different ways, making the particles and forces we see. Each type of vibration corresponds to a different particle, and the way these particles interact gives rise to the forces of nature. It's a beautiful and elegant idea that brings a sense of harmony to the chaotic world of subatomic particles. This neat idea, simple at its heart, could totally change how we understand the universe. If string theory is correct, it means that the universe is fundamentally musical in nature. The different particles and forces are like the different notes and chords in a grand cosmic symphony. This perspective could revolutionize our understanding of everything from the smallest particles to the largest structures in the cosmos. String theory wants to give us one explanation for everything. It aims to be the ultimate theory of the universe, a single framework that can explain all physical phenomena. This is often referred to as a theory of everything. If successful, it would unify all the fundamental forces of nature, providing a comprehensive understanding of the universe. It tries to connect the worlds of quantum mechanics, which is about tiny atoms and particles, and general relativity, which is about big things like gravity and the universe's structure. These two theories have been incredibly successful in their own domains, but they don't quite fit together. String theory offers a way to bridge this gap, potentially leading to a deeper understanding of the universe. If this big connection happens, it would be a huge leap for science. It would mean that we have finally found a way to describe the universe in a single, unified framework. This would not only be a monumental achievement in theoretical physics, but could also have profound implications for our understanding of reality itself. The quest for this ultimate theory is one of the most exciting and challenging endeavors in modern science. Scientists have been looking for a single theory, a theory of everything, for ages. This quest has driven some of the most brilliant minds in history to explore the deepest mysteries of the universe. From the smallest particles to the vastness of space, they seek a unifying principle that can explain it all. Quantum mechanics and general relativity, the two most important physics ideas we have, work really well in their own areas. Quantum mechanics deals with the incredibly small, like atoms and subatomic particles, while general relativity explains the very large, such as stars, galaxies, and the fabric of space-time itself. But they don't seem to agree when we talk about extreme stuff, like black holes or the very beginning of the universe. In these extreme conditions, the laws of quantum mechanics and general relativity clash, creating a puzzle that has baffled scientists for decades. That's where string theory comes in, offering a bridge between these two different worlds. String theory suggests that at the most fundamental level, everything in the universe is made up of tiny, vibrating strings of energy. These strings can vibrate at different frequencies, giving rise to the various particles and forces we observe. By saying everything is made of vibrating strings, string theory tries to give us one framework that explains both the tiny quantum world and the big universe of space-time and gravity. This unified framework could potentially resolve the conflicts between quantum mechanics and general relativity, providing a more complete understanding of the cosmos. It's a bold theory that could change everything we know about physics. If proven correct, string theory could revolutionize our understanding of the universe, leading to new technologies and insights that we can only begin to imagine. The journey to uncover this theory of everything continues, driven by curiosity and the desire to understand the fundamental nature of reality. Even though it's a neat idea, string theory has a big problem. We can't prove it yet. String theory suggests that the fundamental particles we know, like electrons and quarks, are actually tiny vibrating strings. These strings are so small that we can't see them with our current technology. The theory also requires extra dimensions of space that we can't detect. This makes it incredibly challenging to find direct evidence for string theory. We need way more energy than we have now to see these tiny strings. The energy levels required to probe these minuscule scales are far beyond what our current particle accelerators can achieve. For instance, the Large Hadron Collider, the most powerful particle accelerator in the world, still falls short of the energy needed to test string theory directly. This means we need to think of new ways to gather the necessary energy or develop entirely new technologies. This makes it really hard to do experiments to prove or disprove the theory. Scientists often feel frustrated because the tools and methods we have today are not sufficient. They have to rely on indirect evidence and creative approaches to test the predictions of string theory. This involves complex calculations, simulations, and sometimes even rethinking the fundamental principles of physics. But scientists are clever and are looking for clues. They are constantly brainstorming and coming up with innovative ideas to test the theory. Collaboration is key as scientists from different fields work together to tackle this enormous challenge. They use advanced research equipment and cutting-edge technology to push the boundaries of what we know. They are searching for tiny signs of string theory in the universe. Astronomers and physicists look to the cosmos for hints. By studying the behavior of stars, galaxies, and other celestial objects, they hope to find patterns or anomalies that could be explained by string theory. This involves analyzing vast amounts of cosmic data and looking for subtle differences that might indicate the presence of these tiny strings. These signs might be small differences from what we expect to see, or special patterns in the leftover light from the Big Bang. The cosmic microwave background radiation, the afterglow of the Big Bang, is a particularly promising area of study. Scientists analyze this ancient light for any irregularities or unique patterns that could provide indirect evidence for string theory. Even the smallest deviation from our current models could be a significant clue. String theory says there are more dimensions than the three we see every day. These extra dimensions are curled up and hidden, but they're important for the theory to work. They are also really interesting and make some people doubt the theory. Imagining these extra dimensions is hard. Some scientists think of them as tiny loops attached to every point in our 3D space. Others use complicated maths to understand them. However you think about them, the idea of a universe with hidden dimensions is a fascinating mystery. String theory, in some versions, says there might be a multiverse. This means our universe is just one of many, each with its own rules. These universes might be separated by huge distances in higher dimensions, like bubbles in space. It sounds like science fiction, but it comes naturally from some string theory ideas. The many ways strings can vibrate, each maybe making a different universe, could mean there's a huge variety of universes out there. String theory isn't the only idea trying to connect quantum mechanics and general relativity. Loop quantum gravity is another one. Instead of adding dimensions, it says that space itself is made of tiny loops of gravity at the smallest level. Both string theory and loop quantum gravity could change how we understand the universe. They offer very different ideas about space, time, and gravity. It's hard to prove either one, but they both inspire scientists to find the universe's secrets. Scientists don't all agree about string theory. Some think it's the best way to find a single theory because it's mathematically beautiful and might explain some big mysteries. Others aren't sure because we haven't proved it yet and it's hard to test. This disagreement is normal in science. Big new ideas are often questioned, especially when they change how we think about the universe. The debate about string theory shows how science works, with ideas being tested and changed as we learn more. We don't know yet if string theory, with its vibrating strings, will be the theory of everything or just a nice idea. Scientists are still looking for proof, trying new things and better technology. Whatever happens, the journey has been important. String theory has started new research, brought scientists together, and made us think differently about reality. Trying to understand the universe, even when it's hard,